Okay, so welcome back. And in the previous video of this chapter, surface chemistry, we studied this much. Okay, we just highlighted the important points. We studied what is adsorption, distinction between adsorption and absorption, mechanism of absorption. We did these three topics. I didn't complete the whole sentences, whatever you're seeing, but rather I just you know highlighted the important points. You can just go and watch the previous video and come and then watch this video. So now we will study about types of adsorption. So we are gonna highlight the important things with maybe a different color. Yeah, so they are mainly two types. Okay, so there are two types. So just read the heading, that is types of adsorption, then you read it is two. Then they have weak van der Waals forces. No need to study the rest of the lines. It's not useful. So weak van der Waals forces, we have physical adsorption. If you can see here, physical adsorption or physisorption. Physical adsorption is one, or it is chemical adsorption or chemisorption. Remember these things. Is that clear? So these two types of adsorptions we have. When there is weak van der Waals forces, we have physical adsorption or physisorption, and when it is chemical bonds, then we have chemical adsorption or chemisorption. Then chemical bonds may be covalent or ionic in nature. They can be either covalent or ionic in nature. Is that clear? Chemisorption involves a high energy of activation. So, chemical chemisorption involves high energy of activation. This is important. Activated absorb, that is activated adsorption, means high energy of absorption. High energy is needed for activating that adsorption process. Okay. Sometimes two processes occur simultaneously. Already we know that is nothing but absorption. When two things occur simultaneously. No, no, no. Okay, when what is absorption actually? Absorption is nothing but when adsorption and when absorption takes place simultaneously. Don't get confused how I got just now confused. Here it is that two processes occur simultaneously. Sometimes it happen like that. Okay, when chemisorption and physisorption both occur simultaneously. Okay, so next point is a physical adsorption needs low temperature may pass into chemissorption as the temperature is increased. So here it is. A physical adsorption at low temperature may pass into chemissorption, as the temperature is increased. So here they give a example. For example, dihydrogen. Here you can just see they are telling about this. I'm just studying these lines. Okay, so it is written that, for example, for example, dihydrogen is the first adsorbed on nickel by van der Waals forces. Molecules of hydrogen then dissociate to form hydrogen atoms, which are held on the surface by chemisorption. Okay, so this is an example that when a physical adsorption at lower temperature may pass into chemisorption as the temperature is increased. Okay, when temperature increases, physisorption can change into chemisorption. Now let us see the characteristics. So here in types of adsorption, this much is enough. That it is two. There are two types: physical and chemical. And chemical can have covalent or ionic bond. Chemissorption involves a high energy of activation when compared to physisorption, and the physical adsorption at low temperature may pass into chemissorption as the temperature is increased. Now, characteristics of physisorption: lack of specificity. If you don't read the given thing, it's no problem. So it is like does not show any preference for a particular gas, as the van der Waals forces are universal. Lack of specificity means no specific. It's not specific. The nature of adsorbate. So nature of adsorbate, here almost everything is important. So amount of gas adsorbed by a solid depends upon nature of gas. Okay, depends on nature of gas. Now, so, easily liquefiable gases, that is with higher critical temperatures, that is which is easily liquefiable gases that are highly higher critical temperatures, readily adsorb. They are readily absorbed as van der Waals forces are stronger near the critical temperatures. So understood. Nature of adsorbate is amount of gas absorbed by a solid depends on the nature of a gas. Easily liquefiable gases, that is higher critical temperatures, are readily adsorbed as van der Waals forces are stronger near the critical temperatures. Okay. Then next point is also important that 1 gram of activated charcoal absorbs more sulfur dioxide critical temperature, which is 630 kelvins, than methane, whose critical temperature is just 190 kelvins. It is still more than 4.5 milliliters of dihydrogen, which is critical temperature is 330 33 kelvins. Okay. So 1 gram of activated charcoal, since its temperature is 630 kelvins, what will happen? Adsorption of sulfur dioxide is more. Activated charcoal absorbs sulfur dioxide more when compared to methane because critical temperature of sulfur dioxide is more when compared to methane. Okay, so you can see when critical temperatures are more, like, so adsorption. One second. Adsorption is directly proportional to critical temperatures. We can say when critical temperature increases, absorption will be faster. It will be faster, okay? That is readily absorbed because the van der Waals forces are stronger near the critical temperatures. Okay, I just erased this by mistake. You can just underline it. Now, next is nature, reversible nature. So by the thing only you can understand that physical absorption of a gas by a solid is generally reversible. No need to underline anything else because you can understand solid plus gas can give you gas plus solid can give you solid plus gas plus heat because it is an exothermic reaction, remember. So just underline reversible nature. It's of reversible nature. Now, more gas is absorbed when pressure is increased as the volume of gas decreases. Rechartley's principle. So more gas is absorbed. So more absorption take place when pressure is increased. More absorption is take place when pressure is increased. Why? Because volume of gas decreases. When volume of gas decreases, C. So you can just write that absorption is directly proportional to pressure but inversely proportional to volume. That's the thing. That's the main thing. So absorption is directly proportional to pressure. No need to underline if you just write these points in your short notes. It's easy that more gas is absorbed when pressure is increased. So more gas is absorbed when pressure is increased means directly proportional. As the volume of the gas decreases means inversely proportional. Okay, that's it. So you need to just remember this stuff. Then because we can just here they mention you about Lee Chartier's principle. I'll just underline this for you. This is Lee Chartier's principle because of Lee Chartier's principle. All right, now next. So and the gas can be removed by decreasing pressure. Of course, the gas can be removed by decreasing pressure. You can just write it. Not exactly. Yeah. So gas can be removed by decreasing pressure. Okay, yeah. Now, the physical adsorption occurs readily at low temperature and decreases with increase in temperature again because of Le Chatelier's principle here also. All right. Here also because of Le Chatelier's principle. Important. You can just increase the speed of this because I'm going so slow. Yeah, that's it. So more gas is absorbed when pressure is increased and volume is decreased, and gas can be removed by decreasing pressure. And physical adsorption occurs readily at low temperature and decreases with increase in temperature. Now, surface area of adsorbent. So, of course, see the extent of adsorption increases. Adsorption increases with increase of surface area. Yeah, how much ever the surface area, that much will be the ad- adsorption, right? This is the thing. This finely divided metals and porous substances have large surface areas and are good absorbents. So metals. So just remember, finely divided metals and porous substances are good adsorbents. So finely divided metals and porous substances are good adsorbents. Now enthalpy of adsorption, physical adsorption is exothermic process, yes we know, but enthalpy of adsorption here is quite low. It's low, it's 20 to 40 only. Whereas if you go for chemisorption, it is 80 to 240 if you just see here. Here, see, I'll just directly show you. Chemisorption ka enthalpy it is high. It is 80 to 240 because it makes chemical bonds. Okay, just know this thing, the difference between both of them. Okay, this is because because the attraction between gas molecules and Earth's surface is only due to weak van der Waals forces. That's why what enthalpy of adsorption. I didn't underline this one because it's already there in the subheading. So enthalpy is low, 20. Now characteristics of chemical chemisorption, you can understand high specificity. Okay, because it will occur if there is some possibility of chemical bonding. Only when there is a possibility of chemical bonding, chemisorption will take place between adsorbent and adsorbate. So no need to underline anything. For example, they gave you the example. You can just underline the example because they can give you this example or reaction and they can ask whether it comes in chemisorption or this thing. Okay, that time you need to understand. So just underline this thing. So oxygen is adsorbed on metals by virtue of oxide formation, and hydrogen is adsorbed by transition metals due to hydride formation. Oxygen is adsorbed on metals because of oxide formation, and hydrogen they are adsorbed by transition metals. There is a difference between metals and transition metals because of hydride formation. Oxide formation, hydride formation because of adsorbed on metals and transition metals. Then it is irreversible. By the heading only you can understand it's irreversible. Irreversibility concept. So understand this. It's we know very slow at low temperatures. It's very slow, very slow at low temperatures on account of high energy of activation. Okay, on account of high energy. We'll just underline this also. Yeah. So let us just continue. So enthalpy, we were here, right? Okay, yeah. So very slow at low temperatures on account of high energy of activation. Okay, and the next one, the point which you can underline is absorption increase with rising temperature. That's very easy, bhai. Absorption increases with rise of temperature. Okay. Absorption of a gas absorbed at low temperature may change into absorption at high temperature. We already underlined it. We don't need to underline. And it's favorable. Usually, high pressure is also favorable for absorption. So, high pressure favorable for chemisoption. That's it. No need to underline that chemisop for chemisoption also because we are studying already about chemisoption. How much ever you just don't highlight the things, it will be easy. Just highlight the important words. Okay? And that's it. And surface area, it's like same like physical adsorption. Chemisoption also increases with increase of surface area, so no need to underline. Adsorption increases with increase in surface area whatever might be the adsorption type, whether it is physisorption or chemisorption, whether it is physical adsorption or chemical adsorption. When surface area increases, adsorption increases. Is that clear? Enthalpy of adsorption, we just now saw that high, it is high because of formation of chemical bond, that is, it is 80 to 240 kilojoules. Now coming to comparison of physisorption or chemisorption. It arises because of van der Waals forces, we know this. Chemisoption, chemical bond formation. You don't need to underline, we know this. It is not specific in nature, it is highly specific in nature, it is reversible, it is irreversible. It depends on the nature of gas. So you can just underline this. Depends on nature of gas. More easily liquefiable gases are adsorbed readily. Also depends on nature on gas. Gases which can react with the adsorbent show chemisorption. So reaction should take place in this chemisorption. Reaction should be there. It seems. Here you go. Just underline this here. Depends on nature of gas. Here the main important thing is more easily liquefiable. So if it's better if you just you know, I'll just erase the whole thing and just write depends on nature of gas. So you just underline nature of gas and easily liquefiable, adsorbed readily. Easily liquefiable, adsorbed readily. Again, just underline nature of gas which can react with adsorbent. This much only. Nature of gas easily liquefiable, adsorbed readily. Nature of gas which can react with the adsorbent, show chemistry. Enthalpy we just now saw it. It is 220 to 40 here it is, and here it is 80 to 240. Then physics option, low temperature is favorable for adsorption. It decreases with increase in temperature. We just now saw high temperature is favorable for adsorption. It increases with the increase of temperature. No appreciable activation energy is needed. High activation energy is sometimes needed. Now in physics option, it depends on the surface area. It increases with an increase of surface area. Same with the chemistry option. Physics option, it results into multi-molecular layers, results into multimolecular layers on adsorbent surface under high pressure, results into unimolecular layer. That's it. Remember that. Oh shit. What is that? I just erased the one thing, everything get erased. Yeah. So it is results into unimolecular layer. That is that you need to understand. So this video was all about the about the physics option and chemies option. Okay, that's it we did today. We studied about types of adsorption. Okay, so we'll meet in the next video studying about the next topic, and we will do questions and every other topic about this chapter. Okay, so be tuned. Till then, bye. Thank you so much.